And now in this lecture we find out the radius of a circle. In the drawing we have the right triangle ABC. Inside this right triangle we have this circle, and our mission is to find out the radius of this circle. In addition, we know that this is angle ABC, that is the right angle. This is line segment AS, that is equal to 1 unit in its length. This is line segment ST, that is equal to 3 units. And finally, this is line segment TC, that is equals to 2 times square root of 3 units in its length. I repeat again that our mission is to find out the radius of this circle. So first of all, we define the center of this circle, this point, as O. And we define the radius of this circle, that is the radius that we are looking for in this question, as x. So our mission is to find out the value of x, that is the radius of this circle. In the next step, we join points O and Q together by a straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of this circle, and ends at point Q, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore OQ is the radius of this circle, that is equals to x according to our definition. You can implement here rule 1. I'll take quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and we also have tangent AB. This is tangent AB, that is tangent to this circle. Here at this point, point M. Point M is the point of tendency of tangent AB with this circle. And we also have the radius OM, that is equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule 1. We can actually implement rule 1 in our drawing. In our drawing, we have the radius OQ, that is equal to x, so the radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. Line segment OP is the radius of this circle, that is equal to x according to our definition. And we have the radius OP, that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So, inside this quadrilateral POQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle here, this angle must be equal to 90 degrees in its size. Repeat again that in order to complete the sum of the angles inside this quadrangle POQB to 360 degrees, this missing angle must be equal to 90 degrees in its size. So inside this quadrangle POQB we have 4 right angles, and any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrangle POQB as a rectangle. And we also note that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side QB. But PO equals to X, therefore QB must be also equal to X units in its length. Y equal PO equals to BQ. Likewise, the opposite side OQ must be equal to the OQ must be equal to the opposite side PB in rectangle POQB. But OQ equals to X, therefore PB must be also equal to X, because they are equal to each other. So actually found out that quadrangle POQB is not a rectangle but a square, but because of the fact that all of its sides are equal to each other. Each side of this quadrangle POQB is equal to X. So therefore this quadrangle POQB is a square. In the next step we define the length of this line segment AP as A, and we define the length of this line segment QC as B. Here we can implement rule 10. I repeat quickly on rule 10. According to rule 10, in any circle, if AB is any chord, it's called AB in the circle, and PT is a tangent to the circle, here PT is tangent to the circle, here at this point T, then the following equation will be true, that PT square will be equal to PA times PB, and PT square equals to PA times PB. We can actually implement rule 10 in our drawing. Well, because in our drawing, if we focus on this current start point A, from this current start point A, we have tangent AP, that is tangent to this circle here at this point P, and we also have here chord TS, or the extended chord TS, touches this current start point A. So all the requirements of rule 10 are satisfied. Therefore, we can implement here rule 10. According to rule 10, we get that AP square equals to AS times AT. Again, AP square equals to AS times AT. So, writing down. So if we focus on the terminal start point A, according to rule 10, AP square equals to AS times AT. AP equals to A, according to our definition. Therefore, AP square equals to A square, and it is equals to AS. AS is 1, times 80. 80 in total equals to 1 plus 3. So in conclusion, I actually found out that a squared equals to 1 times 1 plus 3 according to rule 10. So a squared equals to 1 and 1 plus 3 is 4. And 1 times 4 is 4. So in conclusion, I actually found out that a squared equals to 4. Here we'll take a root out of this equation. And finally we get that a equals to the square root of 4, that is 2. So here AP is equal to A, equals to 2 units in its length. Likewise, we implement rule 10 on this common standpoint, point C. So from the common standpoint, point C, we have tangent CQ that is tangent to this circle here at point Q. And we also have the extended coordinates T touches point C. So all the requirements of rule 10 are satisfied, and therefore we can implement a rule 10. According to rule 10, we get that CQ squared equals to CT times CS. Repeat again. If we focus on the common standpoint point C, according to rule 10, we get that CQ squared equals to CT times CS. CQ equals to B, therefore CQ squared is B squared, and it is equals to CT. CT equals to 2 times square root of 3 times CS. CS or SC in total equals to 3 plus 2 times square root of 3. So in conclusion, we found out that B squared equals to 2 times square root of 3 times 3 plus 2 times square root of 3. We will open the brackets on this side of the equation, and we get that B squared equals to 2 times 3 times square root of 3, and here we have 2 times square root of 3 times 2 times square root of 3 equals to 12. Why? Because 2 times 2 is 4, times 4, square root of 3 times square root of 3 is 3, and 3 times 4 is 12. So if we actually found out that B squared equals to 2 times 3 times square root of 3 plus 12. So B squared equals, we have here 12, so we substitute 12 by 9 plus 3 plus 2 times 3 times square root of 3. So in conclusion, I actually found out that B squared equals to 9 plus 3 plus 2 times 3 times square root of 3. This expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to A squared plus B squared plus 2 times A times B. If we just substitute A by 3 and B by square root of 3, repeat again, if we just substitute in this expression A by 3 and B by square root of 3, we get that A squared plus B squared plus 2 times AB equals to 9 plus 3 plus 2 times 3 times square root of 3. But this expression, A squared plus B squared plus 2 times AB equals to A plus B squared. And therefore, this equivalent expression must be also equal to a plus b squared when a equals to 3 and b equals to square root of 3. That is to say, this expression equals to a is 3, so it is 3 plus b is square root of 3 squared. So 9 plus 3 plus 2 times 3 times square root of 3 equals to 3 plus square root of 3 squared, according to this algebraic identity, that a squared plus b squared plus 2 times ab equals to a plus b squared. So those two expressions are equal to each other, and those two expressions are also equal to each other. Therefore, those two expressions must also equal to each other. That is to say, b squared equals to 3 plus square root of 3 squared. We take a root out of this equation, and finally we get that b equals to 3 plus square root of 3. So b equals to 3 plus square root of 3. Square root of 3 is 1.732, therefore 3 plus square root of 3 will be equal to 4.732. So we found out that b equals to 4.732. Yeah. Line segment QC that is equal to b according to our definition is equals to 4.732 units in its length. And we have already found out that line segment AP that is equal to a according to our definition is equals to 2 units in its length. So in the next step, we'll implement the Pythagoras theorem on this right big triangle, triangle ABC. Here by PT is the evolution from Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse on the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and it must be equal to AB squared plus BC squared. So in conclusion, we found out that according to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. What is the length of the hypotenuse AC? From the drawing, it is very easy to see that AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So AC in total equals to 4 plus 2 times square root of 3. And therefore, AC squared will be equal to 4 plus 2 times square root of 3 squared. And it is equals to AB squared. From the drawing, it is very easy to see that AB equals to x plus 2, therefore AB squared equals to x plus 2 squared, plus BC squared. BC equals to x plus 4.732, therefore BC squared will be equal to x plus 4.732 squared. In conclusion, we have found out that 4 plus 2 times square root of 3 squared equals to x plus 2 squared plus x plus 4.732 squared. 4 plus 2 times square root of 3 squared equals to 55.7128, and it is equals to 55.7128 x plus 2 squared. X plus 2 squared equals to x squared plus 2 squared, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 squared, x plus 4.732 squared equals to x squared plus 4.732 squared, that is equals to 22.3918 plus 2 times x times 4.732, 2 times x times 4.732 equals to 9.464x. 2 times x times 4.732 equals to 9.464x. So here, in this side of the equation, we have 55.7128. In the other side of the equation, we have x squared plus x squared is 2x squared. And we have here 4x plus 9.464x equals to 13.464x. And finally we have 4 plus 22.3918, that is 26.3918. In conclusion, we shall find out that 55.7128 equals to 2x squared plus 13.464x plus 26.3918. Here we subtract 55.7128 from this equation. And finally, we get that in this side of the equation we left with nothing, that is to say 0. On the other side of the equation, we have here 2x squared plus 13.464x, and we have here 26.3918 minus 55.7128 equals to minus 29.321. In conclusion, we found out that 0 equals to 2x squared plus 13.464x minus 29.321. Here we divide this equation by 2. And finally, we get that 2x squared over 2 is x squared. And we have 13.464x over 2 is 6.732x. And finally we have minus 29.321 over 2, that is minus 14.66 equals to 0. So, in conclusion, we found out that x squared plus 6.732x minus 14.66 equals to 0. So, this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0. the coefficient A equals to 1, the coefficient B equals to 6.732, and finally the coefficient C equals to minus 14.66. So we just have to put the values of A, B and C in the general formula for x in order to find out the value of x for our specific quadratic equation, x squared plus 6.732x minus 14.66 equals to 0. And the general formula for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Repeat again. We'll put the values of a, b and c that we found for our specific quadratic equation, in this general formula for x in order to find out the value of the values of x for this quadratic equation. So we'll do it now, and we get that x equals to minus b. B is 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. B equals to 6.732, therefore b squared equals to 6.732 squared. This actually equals to 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4 times c, that is minus 14.66, so minus 4 times ac in total equals to minus 4 times minus 14.66, that is actually equals to 58.64 plus 58.64 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So if we found out that x equals to minus 6.732 plus minus the square root of 45.3198 plus 58, or 45.3198 plus 58.64 equals to 103.9598 divided by 2. So x equals to minus 6.732 plus minus, and the square root of 103.9598 equals to 10.196 divided by 2. So here we have two solutions that are possible for x. One is positive solution and the second one is a negative solution. But because of the fact that x, according to our definition, x is the radius of this circle, and the radius is a length, and the length must be a positive number. Therefore, the negative solution for x is irrelevant, because x must be a positive number as a length. Therefore, we take into account only the positive solution for x, and the positive solution for x is x equals to 6.732 plus minus, plus, of course, plus 10.196 over 2, and minus 6.732 plus 10.196 equals to 3.464 divided by 2. So x equals to 3.464 divided by 2, 3.464 over 2, is 1.732. In conclusion, actually found out that the radius of the circle is equal to x is equal to 1.732 units. Repeat again. The radius of this circle x equals to 1.732 units in its length. Okay, so in the next step I will summarize the lecture. In this lecture I found out the radius of this circle. So in the drawing we have the right triangle ABC. Inside this right triangle ABC we have this circle. In addition we know that this is angle ABC, that is the right angle. This is line segment AS, that's equal to 1 unit in its length. This is line segment ST, that's equal to 3 units. And finally this is line segment TC, that is equal to 2 times root of 3 units in its length. And repeat again that our mission is to find out the radius of this circle. So in the first step we defined the center of this circle, this point is O, and we find the radius of this circle, that is the radius that we are looking for in this question, as x. So our mission is to find out the value of x, that is the radius of this circle. So in the next step we join points O and Q together by a straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of this circle, and ends at point Q, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore OQ is the radius of this circle, that is equal to x according to our definition. So we can implement rule 1. One, because we have the radius OQ that is equal to x. The radius OQ is drawn to point Q, that is the point of tendency BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO according to rule 1. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and P together by a straight line. OP is the radius of this circle that is equal to x. We can implement again rule 1 here. Why? Because we have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside quadrangle OPBQ we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrangle POQB to 360 degrees, this missing fourth angle must be equal to 90 degrees in its size. So inside quadrangle POQB, we have 4 right angles. Any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrangle POQB as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So side in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to x, therefore BQ must be also equal to x because they are equal to each other. Likewise, according to the sum rule, in the same rectangle POQB, side OQ must be equal to the opposite side PB. but OQ equals to x, therefore PB must be also equal to x because they are equal to each other. So I actually found out that quadrilateral POQB is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other inside of this quadrilateral POQB equals to x. Therefore this quadrilateral POQB is a square. In the next step we define this the length of this 9/7 AP as A, and we define the length of this 9/7 QC as B. Here we implemented rule 10. Repeat quickly rule 10. According to rule 10 is true in any circle. So in any circle, if AB is any chord in the circle and PT is a tangent to the circle, PT is tangent to this circle here at this point T, then in this drawing the following equation will be true, that PT square will be equal to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule 10 in our drawing. Why? Because in our drawing we have here the common external point A. From this common external point A we have tangent AP, and we also have the extended chord TS touches point A, the common external point A, so all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. According to rule 10, we get that AP square equals to AS times AT. Again, AP square equals to AS times AT. Repeat again, if we focus on the common external point A, according to rule 10, AP square will be equal to AS times AT. AP is A, therefore AP square is A square. AS is 1. AT is 1 plus 3. So in conclusion, I should have found out that according to rule 10, A square equals to 1 times 1 plus 3. So A square equals to 1, and 1 plus 3 is 4. So A square equals to 1 times 4, that is 4. A square equals to 4. We took out of this equation and finally found out that A equals to the square root of 4, that is 2. So here A equals to 2. Likewise, we implemented rule 10 in this common external point C. Why you can implement rule 10 in this common external point C? Because of the fact that from this common external point C we have tangent CQ, that is tangent to this again here at point Q, and we have the extended chord ST that touches the common external point C. So therefore all the requirements of rule 10 are satisfied, and for that reason we can implement rule 10. And according to rule 10, CQ square equals to CT times CS. Again, CQ square equals to CT times CS. And again, if you focus on the common external point C, according to rule 10, CQ square equals to CT times CS. CQ is B, therefore CQ square is B square, and it is equals to CT. CT is 2 times square root of 3 times CS. CS in total equals to 3 plus 2 times square root of 3. So in conclusion, we actually found out that B square equals to 2 times square root of 3 times 3 plus 2 times square root of 3. We opened the brackets on this side of the equation and finally found out that B square equals to 2 times 3 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3 equals to 12. Why? Because 2 times 2 is 4, times square root of 3 times square root of 3 is 3, and 4 times 3 is 12. So in conclusion, we actually found out that B square equals to 2 times 3 times square root of 3 plus 12. So B square equals to, we have here 12, we substitute 12 by 9 plus 3. So in conclusion, we actually found out that B square equals to 9 plus 3 plus 2 times 3 times square root of 3. This expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to the expression A square plus B square plus 2 times AB if we just substitute A by 3 and B by square root of 3. We get that A square plus B square plus 2 times AB equals to 9 plus 3 plus 2 times 3 times square root of 3. But this expression A square plus B square plus 2 times AB equals to A plus B square. And therefore, this equivalent expression must be also equal to A plus b squared when a equals to 3 and b equals to square root of 3. So in conclusion, we should find out that this expression equals to a plus b squared when a equals to 3 and b equals to the square root of 3. That is to say, this expression equals to 3 plus square root of 3 squared. So those two expressions are equal to each other, and those two expressions are also equal to each other. Therefore, those two expressions must be also equal to each other. That is to say, b squared must be equal to 3 plus square root of 3 squared. We took out of this equation and finally found out that b equals to 3 plus square root of 3. Square root of 3 is 1.732, therefore 3 plus square root of 3 will be equal to 4.732. In conclusion, we can find out that b equals to 4.732. Here, b 97QC is equal to b is equal to 4.732 units in its length, and we already found out that 97AP is equal to a according to our definition is equal to 2 units. In the next step, we implemented the Pythagoras theorem on this right big triangle, triangle ABC. Here by PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on this right triangle, triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC square equals to AB square plus BC square. From the drawing, it is very easy to see that AC equals to 4 plus 2 times square root of 3, therefore AC square is 4 plus 2 times square root of 3 square. AB is x plus 2, therefore AB square is x plus 2 square plus BC square. BC is x plus 4.732, therefore BC square is x plus 4.732 square. So in conclusion, we shall find out that 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. 4 plus 2 times square root of 4 plus 2 times square root of 3 square equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square. X plus 4.732 square equals to x square plus 4.732 square, that is equals to 22.3918, plus 2 times x times 4.732, that is equals to 9.464x. So in this side of the equation we have 55.7128, so I copy it here. And the other side of the equation we have x squared plus x squared, that is 2x squared. And we have also here 4x plus 9.464x, that is 13.464x. And finally we have here 4 plus 22.3918, that equals to 26.3918. So in conclusion, we shall find out that 55.7128 equals to 2x squared plus 13.464x plus 26.3918. Here we subtracted 59.7128 from this equation, and finally found out that in this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have here 2x squared plus 13.464x, and we have here 26.3918 minus 55.7128 equals to minus 29.321. So in conclusion, we shall find out that 0 equals to 2x squared plus 13.464x minus 29.321. Here we divided this quadratic equation by 2, and finally found out that 2x squared over 2 is x squared, and 13.464x over 2 is 6.732x, and finally minus 29.321 over 2 is minus 14.66. In conclusion, found out actually that x squared plus 6.732x minus 14.66 equals to 0. So this is the quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 6.32x plus 14.66 equals to 0. In our specific quadratic equation, a equals to 1, b equals to 6.732, and finally c equals to minus 14.66. So in the next step, we just have to put the values of a, b, and c here from our specific quadratic equation inside this general formula for x, in order to find out the values or the value of the values of x for our specific quadratic equation. This specific quadratic equation, x squared plus 6.732x minus 14.66 equals to 0. So we did it, and we actually found out that x equals to minus b. b is 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. b is 6.732, therefore b squared is 6.732 squared, that is 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4 times c, that is minus 14.66. And minus 4 times minus 14.66 equals to plus 58.64 divided by 2a. a is 1, so 2a is 2 times 1, that is 2. So in conclusion, actually found out that x equals to minus 6.732 plus minus go to 45.3198 plus 58.64 divided by 2. So x equals to minus 6.732 plus minus at 45.3198 plus 58.64 equals to 103.9598 divided by 2. So inside the root we left only with 103.9598. So x equals to minus 6.732 plus minus, and the square root of 103.9598 equals to 10.196 divided by 2. So here we have two solutions that are possible for x. One of those solutions will be a negative solution, but the negative solution is an incorrect solution. Why? Because of the fact that x, according to our definition, x is the radius of this circle. So x as a radius must be a positive number. Therefore, the negative solution is the incorrect solution, and we'll take into account only the positive solution for x. And the positive solution for x is that x equals to minus 6.732 plus 10.196 over 2. And minus 6.732 plus 10.196 is 3.464. So x equals to 3.464 over 2. 3.464 over 2 is 1.732. So actually found out that the radius of this circle x is equals to 1.732 units. Okay, thank you very much.